Hello friends, welcome to EPG Padasala. I am Dr. Karpagam Chinnamma from Chikana Government Arts and Science College, Tirupur. Today we are going to deal with an important finish, crease recovery and wash and wear finish. The primary function of clothing is to prevent the loss of body heat and to allow the sweat to pass through it to the outside atmosphere. Cotton is good in each of these functions. These properties, together with its hydrophilicity, durability, ability to withstand rough laundering, good perspiration absorption, comfort during wear, ability to take up a wide range of dyestuffs, freedom from static charge generation, and pleasant natural feel make it an excellent and comfortable fiber for apparel. However, cotton has certain deficiencies in properties, and finishing is required to improve these properties to maximize consumer usage and acceptance. One of the major shortcomings of cotton is that it is prone to creasing during wear and washing. The formation of creases is an undesirable property to apparels, so it has to be made crease resistant. A treatment with cross-linking agent is given to impart wrinkle-free properties to cotton. This finish imparts crease-resistant properties to cotton and keeps shrinkage under control. The object of this finish is to keep the fabric flat and smooth and free from undesirable creases, so the finish is referred to as anti-crease, crease-resistant or wrinkle-free finish. Fabrics treated with these finishes tend to smooth out when properly hung after wearing. It's also called resin finishing, as resins are used for this finish. This is a chemical and permanent finish. Usually, crease resistant and wash and wear finishes are applied to cellulose fibers, that is cotton, linen, viscose and rayon. From this session, we would learn about crease recovery and wash and wear finishes, get an insight into the finishing agents used for these finishes, be acquainted with the process of application of these finishes, and be aware of the various care properties for the finished fabric. Crease resistant finish. What are the causes of wrinkles or creases? Cotton cellulose chains contain hydroxyl groups in both amorphous and crystalline region. There are hydrogen bonds between the hydroxyl groups of the molecular chains. When a load is applied on the cotton fabrics, the cellulosic chain in the fiber bends. Hydrogen bonds between the molecular chains in the amorphous region break and allow the chains to slip past one another, and this bending remains permanent since cellulosic chains are inelastic. The bending of the cellulose chain of the fiber under the application of load causes the formation of crease. The primary cause of shrinkage of cellulosic fibers is the fact that these fibers can readily absorb moisture. The absorbed moisture facilitates internal polymer chain movement in the amorphous fiber areas by lubrication. It disrupts the internal hydrogen bonding between these polymer chains. When a moisture-laden cellulosic fiber is stressed, the internal polymer chains of the amorphous areas are free to move to relieve the stress. Hydrogen bonds can reform between the polymer chains in their shifted positions. With no restoring force available, a newly formed wrinkle or crease will remain until additional process like ironing apply adequate moisture and mechanical forces to overcome the internal forces. The swelling of cellulosic fibers by moisture can be reduced by application of self-cross-linking urea or melamine products, as well as products that cross-link with cellulose. Without such a cross-linking finish, cellulosic fibers can take up more than 10% of their weight in water. As the fiber swells, the fabric must crease and shrink to relieve the internal stress caused by swelling. How can the creases be prevented? The method of minimizing the formation of creases involves the reaction of the hydroxyl groups of adjacent cellulose macromolecules with some cross-linking agents. The introduction of cross-links imparts dimensional stability and elasticity to the fibrous material and make it crease resistant. The most commonly used cross-linking agents are resins. The resins react with the hydroxyl group in cellulose to form a bond which gives good recovery from creasing and improved dimensional stability. The resin cross-links cellulose chains, and they do so in the amorphous regions of the structure where the spacing between fiber molecules is relatively open. The effect of this is to give a more crystalline character to the fiber, so that if the fiber is distorted, it will have a greater tendency to spring back to its original position. If the fabric is cured with a resin in a flat configuration, it will have a tendency to recover to the original flat position. The finishing agents for imparting crease recovery. The finishing agents used in crease recovery finish are resins, catalysts, polyethylene emulsions, wetting agent and softeners. Resin or cross-linking agents. Resin cross-links give fibers a memory and good wrinkle recovery. Resins are of two types, deposition and cross-linking type. Cross-linking type of resins are used for this finish. This type of resins chemically react with the fiber and cross-link the fiber molecule. This type of resin finishing is durable and much better than deposition type of resin finishing. These are also known as N-methylol compounds, as the methylol groups are attached to the nitrogen. Though these compounds are commonly called resins, calling them as resin precondensates is correct. The precondensates further polymerize to form resins. The resin precondensates are used for this kind of textile finishing and not resins. The following cross-linking type of resins are mostly used for crease-resistant finishing. DMU, that is dimethylol urea or urea formaldehyde. DMEU, that is dimethylol ethylene urea. DMDHEU, that is dimethylol dihydroxyethylene urea. Dimethylol ethyl carbamate. DMPU, that is dimethylol propylene urea. TMM, that is trimethylol melamine or melamine formaldehyde. They can be grouped as formaldehyde and non-formaldehyde containing resins. Formaldehyde containing resins. Formaldehyde containing resins can be classified as urea formaldehyde resin, melamine formaldehyde resin and glycosyl resin. Urea formaldehyde resin are highly reactive, have low stability to hydrolysis and low durability to laundering, high chlorine retention, high content and release of formaldehyde, very high elastic resilience, melamine formaldehyde resins. These products are mostly 3 to 6 reactive N-methylol groups connected to one melamine ring. This leads to higher cross-linking and easy care finishing with better wash fastness. These products provide tri to hexamethylol melamine, that is TMM, and their methyl ethers. TMM is preferred for easy care finish, often only as a component of product mixture to give a better performance of effects. Properties of melamine formaldehyde resins are better stability to hydrolysis and better washing durability, relatively high formaldehyde content and release, better chlorine retention than DMU, more dimension stability and stiffness. Glycol resin or DMDHEU. This chemical is the basis for about 90% of easy care and durable press finish products in the market. It is synthesized from urea, glyoxyl and formaldehyde. It's less reactive than DMU and TMM and therefore requires more active catalyst. It's more stable than finish bath with DMU and TMM. Properties of glycol resin: low to very low reactivity, excellent durability and laundering, low chlorine retention, medium to very low formaldehyde release, and most commonly used durable press products. How can formaldehyde release be reduced? Formaldehyde released can be reduced by after washing of cured fabric, addition of formaldehyde scavengers like carbohydrazide to the bath, use of urea in the pad bath, or application through spray and modification of DMDHEU. Non-formaldehyde containing products, the DME-DHEU does not contain formaldehyde. It is derived from the relatively expensive dimethyl urea and glycol. Like DMDHEU, it can be modified by reaction with alcohol such as methanol and diethylene glycol. These products are less reactive than DMDHEU because of the hydroxyl groups. Stronger catalysts or harsher conditions are needed for successful cross-linking. It costs twice as much as DMDHEU. To achieve comparable easy care effects, nearly twice the amount of DME-DHEU is needed. The properties of non-formaldehyde resin: they are formaldehyde free, very low reactivity, limited durability to laundering, development of unpleasant odor. Commercially, it is modified DMDHEU that is most used today. This product is pre-buffered to prevent premature curing and also pre-blended with a catalyst. Effective cross-linking reactant should be very stable, soluble in water, and remain colorless during heat curing. Moreover, they should not be toxic, odorous, or irritating, and should be available at low cost. Now that we learned about resins, let's look into the next chemical required, a catalyst. Catalyst facilitates cross-linking reaction. Magnesium-based catalysts are the most popular in use today. The reaction of DMDHEU with cellulose requires an acid catalyst. The most common catalysts are magnesium chloride and zinc nitrate that generate acid conditions during curing process, thus providing neutral liquors and good finish bath stability. Sulfuric acid and hydrochloric acid and their ammonium salts serve as excellent catalysts but also lead to undesirable fiber degradation. Often, citric acid is combined with magnesium chloride to provide additional boost to reactions. Citric acid or aluminum chloride can also be blended to increase catalysis when curing times are short. Polyethylene emulsion. A high-density polyethylene emulsion restores some of the lost tear strength and abrasion resistance by providing lubrication and imparts hand and sewability. Wetting agent helps to achieve quick wetting and even distribution or penetration of resin. A softener imparts soft hand to the finished product. Let's see how the resin precondensates are prepared. Urea formaldehyde precondensates were successfully used to deposit the resin in the fiber. Under neutral or slightly alkaline condition, urea and formaldehyde condensate to give dimethylol urea, that is DMU. These products are known as precondensates, are highly reactive and can react further. Therefore, dimethylol urea is further methylated to give a stable product which is crystalline and readily soluble in water. These precondensates are of a molecular size sufficiently low to penetrate the amorphous regions of cellulose. When heated under acid conditions, these condensates form urea formaldehyde synthetic resin. The amount of urea and formaldehyde to be taken in the ratio 1:1.6, which give optimum effect. In the first process, urea is dissolved in formaldehyde solution 40% at room temperature for 4 to 6 hours with periodical stirring, and with addition of ammonia, and the temperature should not exceed 35 degrees centigrade. In another process, the precondensates are prepared by treating formaldehyde solution, adjusting its pH to 7 by adding sodium hydroxide. The pH of the mixture is raised to 9 with sodium hydroxide solution. Equal amount of water is added and the contents are gradually heated to 80 degrees centigrade. The temperature is maintained at 80 degrees centigrade for 15 minutes and cooled rapidly. The precondensates are marketed in the form of a colorless liquid which can be mixed with water in any proportion. Melamine formaldehyde precondensates also polymerize to insoluble resins at high temperature under acidic condition and are used for making cotton fabric. Trimethoxymethylmelamine (TMM) and hexamethoxymethylmelamine are two precondensates commercially available in liquid form. Like urea formaldehyde precondensates, they are used after dilution for padding the fabric followed by curing at 150 degrees centigrade. The finishing process. The cross-linking agents are applied by pad, dry and cure process. The application of urea formaldehyde resin consists of the following steps. Impregnating by padding. Before impregnation, the fabric to be treated should be in a highly absorptive condition, hence the material should be scoured and bleached for better penetration of liquor. Dyed and printed fabrics can be taken directly. The fabric is padded by using either 2 or 3 bowl padding mangle with precondensate solution 100 to 300 grams per liter containing an acid catalyst like diammonium hydrogen phosphate or ammonium chloride and other additives such as softener and wetting agent with a pickup of about 80% at room temperature. Wrinkle-free finishing can also be imparted using dimethylodin hydroxyethylene urea resin 40 to 120 gram per liter with magnesium chloride 10 to 25 gram per liter as catalyst, non-ionic silicone softener 40 gram per liter, polyethylene emulsion, citric acid and wetting agent, and acetic acid to maintain the pH bath at 4 to 4.5. Drying. After padding, the material is dyed in stentor with minimum tension at 70 to 80 degrees centigrade. Higher temperature of drying leads to migration of finish causing loss in tensile strength and abrasion resistance of fabric. Curing of the impregnated material. After drying, the material is cured at a high temperature of 120 to 150 degrees centigrade for 2 to 5 minutes using dry heat in a stentor machine. Polymerization of resin and cross-linking of molecular chains take place during the curing process, thus crease resistance is achieved. Washing and soaping. After curing, the material should be washed in open width or rope form in a dilute solution of soap and 1 to 2 gram per liter of anionic wetting agent like TRO and 2 to 4 gram per liter of soda ash at 50 to 60 degrees centigrade for 10 minutes. The purpose of this washing is to neutralize the residual acidity and also to remove the unfixed resin. Softening and dyeing. After washing, the material is rinsed in water containing softening agent. Then finally, it's stentored in ordinary stentor to dry and get even width of fabric. The major application methods are pre-cure, post-cure, garment dip, spray application and vapor phase. These have been discussed already under durable press finish, and pre-cure is the most commonly adopted method. Let's now have a look at the characteristics of these finished products. The resulting fabric from such a process would have an improved crease recovery. However, in addition to improving the crease recovery, it was also found that resin finishing improved the case of maintenance and dimensional stability of the fabric to washing. So, a fabric which had a greater wash shrinkage would have lesser shrinkage after the resin treatment. It has less tendency to pilling and improved wet fastness of dyes and prints. The effect of resins on fabric. Resins do, however, have several effects on the fibers. Excessive cross-links causes brittleness, stiffness and harsh feel, giving loss in tear tensile strength by 30 to 40% and abrasion resistance. Tear strength can be improved by optimum selection of additives and softeners, but it has no improvement on tensile strength. Absorbency is reduced and so the fabric becomes uncomfortable in warm, humid weather. Resins have an affinity for oily soils. Hypochlorite bleaching causes chlorine retention, that is, chlorine from hypochlorite is retained by the amine group of the resin and results in loss of crease resistance. Chlorine in association with the amine groups forms chloramines and results in yellowing of fabrics. Melamine formaldehyde products do not absorb chlorine, but the treated cloth becomes yellowish and the crease resistance is not satisfactory. The fabrics for wrinkle-free finish. The base fabrics must have sufficient strength to withstand 40 to 60% loss in tensile and tear strength and still maintain sufficient strength to provide a garment of acceptable wear life and durability. It must also have excellent absorbency to allow resin to penetrate into the interior of the fiber and form crosslinks. If fabric is dyed, the dye must be fast to acid catalyst and high temperature. Fabric must be free from size as it may react with the resin. Fabric pH should be between 6.5 to 7. Wash and wear finish. It's also called drip dry finish or easy care finish. Cotton fabrics or other cellulosic like rayon and linen crush badly when in use. When wash and wear finish is applied, cellulosic fabrics acquire qualities similar to that of synthetic fibers. They become easy to maintain as they dry smooth, do not wrinkle and need little or no ironing after washing, that is, wash, dry, wear and no need for ironing. The fabrics have a good soft hand and a neat appearance. Treated fabrics become less moisture absorbent, thus they dry easily and rapidly. This finish is a durable one. The fabric is saturated with resin and cured at temperature of about 360 degrees Fahrenheit. The fabric becomes stiff, less absorbent and more resistant to wrinkling. Tensile strength and abrasion resistance are reduced. The finishing agents for wash and wear finish are also the same, that is the resin precondensates. The process sequence of wash and wear finish. This process involves two major steps such as polymerizing and then cross-linking. The fabrics are cured twice in this process. Different catalysts are used for these two purposes. This method of resin application gives wash and wear finish to the garments. The fabric is padded with a composition of resin, polymerizing catalysts like zirconium acetate or lead acetate, and wetting agent. The padded fabric is dried at 80 degrees centigrade for 8 minutes and cured at 160 degrees centigrade for 5 minutes. Then it is washed and dried. Or without drying, it goes to the next step, that is padding with cross-linking catalyst, example magnesium chloride, dried at 80 degrees centigrade for 5 minutes and cured at 160 degrees centigrade for 3 minutes. It's given hot rinse, cold rinse and dried. Let's have a look at the care practices for these finished fabrics. General care guidelines for crease recovery and wash and wear items include the following. Some of these finishes cause yellowing when a chlorine bleach is used. So labels on the material should be read before using a bleach. The garments must not be wringed or spin dried in washing machine or in a dryer. It must be rinsed well and hanged on a wooden or plastic hanger, buttoned and straightened out and allowed to dry. Metal hangers may cause rust stains. Some garments tend to pucker at the seams when they dry. Some require quick, light ironing with a cool iron. Items must be washed frequently because resins have a strong affinity for oil and grease, so that oil penetrates deeply and builds up. Stains, collars and cuffs must be pre-treated. Use a spot removal agent on grease spots. Wash loads must be kept small to minimize wrinkling. Items must be removed promptly when dry. Garments must be laundered inside out to lessen abrasion, since this will reduce the wear on the finish. So let's summarize what we dealt with in this module. Specific characteristics not present in fibers are imparted through functional finishes, thereby adding value to the fabric. One such important finish is crease resistant and wash and wear finish. In this module, we have learned what is a crease resistant and wash and wear finish, the chemicals and process involved, and the care for the finished fabrics. The durability of the finish depends on its quality, the amount of fabric saturation, the care in applying and curing it, as well as the care with which the consumer follows the instruction on the garment label. To overcome the boundaries of using resin, researchers have employed titanium dioxide nanoparticles to improve the wrinkle resistance of cotton. Hope you enjoyed this session. So wear a wrinkle-free dress. Bye for now.